Alright, hello my wonderful students. This is part 2 of Foldable number 1, graphing the sine function. For this one we have y is equal to 1/2 sine of 2 theta, and this is more similar to the function that the function that we're supposed to use, which is y is equal to a sine of b theta. We actually have an a here and a b here, so we're going to be able to use the amplitude and the period to make adjustments to our parent function. So for this one here, we're going to look at our amplitude again. And remember, our A is just basically that's here. What's the amplitude? And we just see that it's 1/2. This is great. That means the distance from the center is going to be 1/2 up and 1/2 down. So let's just say this right here is 1. This is -1. That means this right here would be 1/2. And this also will be -1/2. Something I didn't do in the other one, but I'm actually going to go and show you this part here. So if I just mark this right here, it's kind of like an asymptote, but not really. It's just showing you that our graph is only going to live inside here. So I'm not really sure where it's going to be at yet, but I know it's only going to live in here. It can't live above because the amplitude's only 1/2, so it can only be distance from the center up 1/2. Distance down from the center up 1/2. Even if this was negative, or this one here, sorry, was negative, the amplitude would still be positive because the amplitude is based off of this absolute value right here. Okay? Because, distance can never be negative. All right. Now we can go ahead and work on our period. So our period is equal to, once again, it's 2 pi over b. And in this case, our b is actually 2. You can see our b here. So this is going to be equal to 2 pi over 2. Right away we can see that the 2's reduce or divide to be equal to 1. So this is going to be pi times 1, which is pi. So our period for this one is only going to be pi. If we notice in the last one, our period was 2 pi because we had no b to divide. So this is going to be a distance right here of pi. And then once again, we're going to cut this in half. And we're going to get pi over 2. And then we're going to cut pi over 2 in half and get pi over 4. And then we're going to go ahead and cut between this one and this one. If we get pi over 2 plus pi, in order to do this, we have to multiply pi by 2 over 2. And then we can get pi over 2 plus 2 pi over 2. Remember, we only have to do that because in order to add these together, they have to have the same denominator. So we're going to have equals to pi plus 2 pi is 3 pi, and then over 2. So that's what's going to be here, 3 pi over 2. And once again, since we're doing the sine function, we always start at 0. And we're going to go up, touch the maximum, go down, midpoint, or the 0, go down, touch the minimum, and go up and touch the 0 again. And once again, we're going to do a nice curve, sine curve. And this is, like I said before, this is only one cycle. Technically, pi goes infinitely this way forever and infinitely this way forever. But this is just the cycle that we're looking for. So when I asked you to graph a cycle of, oh my God, what is that? To graph a cycle of the sine graph of this, that means it's going to be within here. Okay, so it's just been one cycle. If I ask you to graph 2 cycles, you can graph a cycle here, you can graph a cycle positive or a cycle negative, it's up to you. But you just have to know it goes to the maximum, goes back to 0, minimum goes back to 0, and that's one cycle. Just like if you were to put this together, it would make kind of like a circle. This part would be there, and this part would be the part that goes underneath.